Now the main part of how we could calculate the line to line voltage. There are simply line to line voltage that I have told you previous lecture, that VAB, the status of VAB, VBC and VCA. Then we find this VP 0 degree minus VP 1 minus 120 degree, and how we could calculate it. Pretty much simple thing. You have to just calculate it in complex number. Okay, I will show you a simple mathematical tool. Take it as theta, that means the angle. That means cos theta plus j sin theta. Okay, if you want to convert, again I say, if you really want to convert a phasor term to its complex term, you can use this equation. Just put the value of angle here. VP is similar. VP is quite similar to both. You can easily take a common from it. That will not do anything. Just put the 0 degree from here. Cos 0 degree means 1. If it is cos 0, it will be 1. And if it is a sin 0, it will be 0 degrees. Sorry, that can be it's minus. It is a cosine form, so you have to give minus, not sinusoidal form. If it is sine, it will be plus. So it will be minus. Now, after putting this, cos 0 degree means 1. Okay. Similarly, sine 0 degree means 0. So it will happen. Sorry, I'm right here. It will be plus, not minus. It will be plus, not minus, because there is a minus. I have overlooked it. This minus will come here. Just calculate it. Then the cos minus 120 degree. Cos minus 120 degree means minus half. Minus means plus, and sine minus 120 degree means minus root 3 by 2. Minus means plus. And after calculating these two things, 1 plus half and j root 3 by 2, we can write it like this: root 3 VP 30 degree. You can also similarly change this in your calculator too. If we just convert these phasor to complex diagram, you can easily calculate it. Okay, so similarly we can see VVAC, VCA like this: 30 degree, 90 degree, 210 degree. And you can see there are each voltages are root 3 multiplied by root 3. The magnitude of the line voltages VL is root 3 times the magnitude of the phase voltage VP. That means in that position root 3 VP are here. That is VL. The line voltages VBC is VL. It is a balanced 3 phase, so each of the magnitude will be same. And as you can see, VL is equal to root 3 VP, as these three things are common. So VP, VAN, VBN, VCN all are equal. VL means VAB, VBC and VCA. All three things will be equal, as it is a balanced 3-phase network. And from this we get this equation: VL is equal to root 3 VP. If anybody asks in that particular point that the phase voltages are given in circuit diagram, you have to find out line voltages. That will be VL equal to root 3 VP. Okay, in Y connected, YY balanced connection. Okay, and you can try vice versa too. If you know as VL, you can find out VP divided by VL divided by root 3, you can get VP2. So that is an equation that is pretty much important. And the interesting fact is that the voltage leads their corresponding phase by 30 degree. Here you can see that is 30 degree and minus 90 degree and minus 210 degree. It is a balanced YY connection. As we know, the difference between these two is 120 degree. The three things are 120 degree apart to each other, but they leads by 30 degree. That means there is another annotation and important theorem we get, that VL, which is line voltage and phase voltage, are line voltage leads phase voltage by 30 degree, and line voltage is root 3 times greater than phase voltage. So these two things we can get from there. Okay, so from this we can also get we can also use KVL to find out the to apply KVL, then find out the current from here, that after we adding up our line currents, that will be 0, and that will be equal to the neutral current. And we have to keep on our mind that one thing, that a balanced load has 0 neutral current. Okay, there will be no neutral current will be passing through its neutral, as it is a balanced line. Okay, now that is the equation of a line current. Means each line carries phase voltage, so VAN divided by, if it's a balanced 3 phase, so you can just have to just divide it your Y connected phase load per phase. Okay, that will be enough for you to understand this. As you can see here, if it's a line current IA, there is only ZI and VAN, so VAN divided by ZI, you will get the IA. It's a balance, so there will be no neutral current, and neutral current will be 0 ampere. So all are well. If any kind of neutral current passes through, that will be an unbalanced load. Okay, so in a balanced load we have come to know that equation VL is equal to root 3 VP, that means root 3 times greater, and also 30 degrees apart from its phase voltage. So my dear students, we have learned a lot of things that will help us to understand quite the mathematics of the YY connections. In the next lectures, next day, I will try to give you some lessons on the examples, that how we could really solve this kind of mathematics. By then, keep faith, stay healthy, and bye bye.